All right, so brand new chapter, exciting stuff, right? Yeah. Do you remember simplifying square roots? Yeah. What's one thing that we did this year you didn't do a ton of before, but I think we've done it this year. Remember, like if I had 1 over the square root of 2, could I leave it like that? No. So what do? This is just an example of the kind of stuff that we're going to be doing in this chapter, all right? There's a lot more to it than just this, but this is just one little sneak peek at the kind of stuff we're going to be doing. Remember this? It's called rationalizing the denominator, multiplying top and bottom by the square root of 2. So what's that? Square root of 2 times square root of 2 is just 2. And then the top is just the square root of 2. All right? So it's not exactly what we're going to be doing today, but we'll eventually get to stuff like that. But we've already talked about that before, haven't we? Okay, I said, remember in Algebra 1, you probably learned how to do this. And everybody's like, what? Algebra 1? I didn't do anything in Algebra 1. But this is the kind of stuff that we're going to do. All right, so let's start with something really basic. I thought about not even doing this, but it's in the book, so we might as well do it. I probably won't even mention that too much. I forget what class it was, but somewhere in one of the problems it said something about the radical. And like, radical, Mr. Hammer, what was a radical? I didn't know what the radical was. Well, that little check mark looking thing, that's a radical. Okay, so that's a radical sign is what they call it. All right, so that little check mark looking thing, that's considered to be the radical. The thing inside of it is the radicand. This may be the last time I ever refer to that as the radicand. All right, I'll probably just say the number it's inside the square root or the cube root or the fourth root or whatever. All right, but that's all right. But it's got a number. It's called the radicand. And again, I probably will not refer to this as this, but you never know. Somebody might. All right, you might see on an SAT or a PSAT or something like that. It might use this word, so I guess it would be good to know. They call that the index. This is a little number that's kind of like tucked in that little check sign, all right? And we've talked about cube roots, haven't we? Have we? I don't know, maybe in here we haven't, but in your Algebra 1 class, didn't you talk about a cube root and a fourth root? And that you never talked about a cube root? Okay. Oh, okay. So let's do this. Let's talk about that real quick here. So if I took the square root of a number, what is the n? If I wrote the square root of 9, what is the index? It's a square root. So it's what number is being squared to give you 9. What number times itself, right? What number squared is going to give you a 9? That would be a 3. But what is this number right there that you don't see? Because of square root, we never put a number there. It's a 2. Why is it a 2? It's a square, right? It's the square root. So what is that? 3 what? No. How do you say it? No, 3 squared. 3 squared. So if you go the opposite, that's 9, right? What if you wanted to go back to get the 3? What would you do? You would take the square root, and the square is a number what? 2. So technically, you could put a 2 there. All right? I think they usually have a little thing out like that, but I never write it like that. But technically, a 2 should go there when it's the square root. All right? Did you know that? All right. Why is it a 2? Because you're asking yourself, what number times itself? How many numbers? Look at me. Look at me. How many numbers? A number times itself. How many numbers? 2 numbers, okay? And they both have to be the same number equals 9. What is it? It's a 3. Would you agree? That's a square root. And you've never heard of cubed root? Oh my goodness. Cubed. C-U-B, watch. Cubed. C-U-B-E-D. Okay. Everybody watching? You learn like 2 cubed, 3 cubed, 4 cubed, 5 cubed, up to 13 cubed.
We had to do it in one class period, and the teacher wouldn't let us go to lunch.
No, 13 cubed is way more than 169. Yeah.
Read as 13 squared.
Yeah. I don't even know what it is. 13
Then which one?
cubed. It's 2197. All right. I don't know a whole lot of these, but I know a few of them. All right, listen. Shh, shh, shh. Hey, come on. You're wasting my time. Listen to me. So the square root of 9 would be 3. What's the cube root of 8? What are you asking? What number, multiplied by itself 3 times, or what number cubed, okay, is equal to 8? So like if I put a number here, here, and here, and here. Yeah, x would be what? 2. So what's the cubed root of 8? It's equal to 2. Why? Because 2 cubed is what? Is 8. Yeah. Make sense? And we're going to use that in this lesson. That's why I'm talking about this, because, but that should be something that you already knew from Algebra 1. But if it isn't, that's what I'm showing you now. Let's stick with cube root. I can't do a lot of these in my head. I could use my calculator. What if I had the cubed root of 27? What's the cubed root of 27, or the cube root? It's 3, because 3 times 3 times 3 is 27. Agreed? Okay, so that's what we mean. What if I said the fourth root? I'll try to do an easy one. Now this one we use a word, cubed. We could say the third root. We technically could say what? Instead of the square root, we could say the second root, okay? A lot of teachers, a lot of people just, when they do square roots, like if I said the square root of 16, I always say square root. I noticed Mia, when she was doing it, she said root 16. Didn't you? I don't really like saying that because these are all roots, okay? But you see this so much that teachers just decide, if you just say root something, that means it's a square root automatically. And that's fine. I don't have like a big issue with it, but I don't usually say that because you have other roots. You got a third root, fourth root, fifth root, and whatever number root, okay? So I would say square root of 16. Everybody with me on that? So what number times itself? What if I had this, though? What if I had the fourth root of 16? What does that mean? That means what number, if I take it to the fourth power, am I going to get a 16? Like, what number times itself, times itself, times itself, 4 times, same number has to be 16. 2 is, right? Because 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root, so we don't have like a fancy word for this. We have a square for square root, right? Second root. We have cube root for a third root. After that, no more fancy names. We just say fourth root, fifth root, sixth root.
Is it -2?
Well, kind of. We're going to talk about that in a few minutes, okay? Everybody with me on that? Okay. I will do a few of these. They do them in the book for the... yeah, let's just do it like this. So they say this. The square... 3 squared is 9, correct? That means if you take the what? The square root of 9, what are you going to be left with? That number underneath it, that base. Okay, you got a base and an exponent, okay? You see that? So if I take the square root of 9, what's that going to equal? Whatever that number is right there, okay? We already did this. We'll do it again. What if you had this? What does that mean? That means if you take the cube root of 27, right, what do you get? You get that base, which is 3, right? These all work out the same thing, but it's the idea that matters. So what's this? How do I get to the 3? What do I do to that 81 to get to that 3? I take the what? Not the square root, but the fourth root, okay? Because the square root would be something different. What would the square root of 89 be? Or 81 be? It'd be 9. I was thinking 9, so I said 89. But what's the fourth root of 81? It's 3, because 3 to the fourth power is 81. Everybody see it? Do one more. I could keep doing this all day. And Mia said she did this up to 13, okay? And her... Oh, it's squares, okay. So 3 to the fifth is 243. So if you saw, and it's nice to know those numbers, because if you see them right away, you're like, oh, yeah, that's a cubed root, all right? So what is the cubed root of 243? It's what? I'm sorry. Not cubed root. What am I doing? Somebody stop me. What is it? What root? Fifth root. Right. What's the fifth root of 243? It's 3 again. Okay? You got it? All right. Let me just pick some random number. I'm going to put it into a calculator, get some big number that I don't have any idea. Let's go 5 to the 6th power. Okay, this is stupid, but it's 15,625. And I said it was to the 6th power, right? So this would be the what? The 6th root of this, all right? You can actually do that on your calculator. You can actually do a 6th root on your calculator, all right? So there's my 15,625. Now it ends in a 5, so that gives you a hint of what it possibly could be. Wouldn't you agree? So if I take the, you got a button. Here's the button on my calculator looks like this. It's the xth root of y. So again, depending on your calculator, not everybody's, but some calculators do things differently. On the calculator I'm using right now, what I would do is I would put this number in first and then take the 6th root of that number. Now, some of your calculators, you would hit the 6th root first and then you would put that number in. All right? So I forget what I've done already. Let me clear it. 15,625. And then I'm going to hit I have to hit shift. And then I hit the 6th root. And that gives me 5. Yep. So see if you can do that on your calculator. I don't even think they're going to ask you to do that on these homework problems. But it's just nice to be able to know how to do a different root besides just the square root on your calculator. Okay? So make sure you know how to get that. Again, whatever calculator you're using could be different than what I'm using. It's either one way or the other. You either hit 15,625, then you hit the 6th root, or you hit 6th root first, and then you hit 15,625. It's one of those ways. It's either one of those ways. So just make sure you know how your calculator works. Nah, it'll work. How do you get what? Here, let's go to this one. Yeah. So if you have a calculator like this, you'd hit the 6th root. Now I never use this calculator. Oh, you're right. I don't see it on here. It's probably in one of the menus or something. It could be in, no, that's not it. It could be in mode. No, I don't think it's mode. Yeah. See, I rarely ever use this calculator. So I don't see it. What if you wanted just to make some guesses? What would you do? Just start throwing some numbers in there and take it to the 6th power, right? So let's try a 3, all right? So 3 to the 6th power. So this would, now again, I got to find out where that button is. See, on my calculator, that's why I like where is it?
Left-hand side, right, diagonal of the center.
I can only do up to the cube root.
No, that's just a square and a square root. Yeah, math. That's what it is, math. All right, so you hit math first or you hit the...
That one only goes up to the cube root. But...
Yeah.
So mine goes all the way up. Yeah, it does. You can throw in a number.
I have that one.
Maybe, what if you go to number?
No, you're gonna click 5. Go back and click 5.
Oh, yeah, it's right there. Yeah, it's the, yeah. Okay, so... Okay, so you put the number in first. Well, I don't know. Let's try it. 15,625. If anybody's watching this on YouTube, you're not seeing anything I'm doing because you don't see the calculator on here. Yeah, I didn't think that would work. So on this one, you actually hit the 15,625 first, then you go to math, then you go to 5, and then it should give it to you. So 15. This is an older version of a graphing calculator, right? Go to math, and then you'd hit 5, and then you hit enter, and it's an error. I don't know.
No, you clicked it because it's X. It doesn't know what.
Oh, to the 6th root, right? Of course. Let's go back. Let's try it again. So do you hit the 15, 6, 25 first, or you hit the 6 root first? Or you go to math first?
Yeah, go to math.
Go to math first, then you hit 5.
And then click the arrows to go back to the X. That's what I did.
Oh, okay. So you hit a 6 right there. Oh,
Mine's different then.
yeah. I don't know.
You plug in the numbers. So you fit 5 and then math. And then
Well, you don't know it's 5 yet.
oh.
So you got to put it in a 6. I don't know. Somebody figure it out. Let me know later. All right. Because okay, go ahead. Whoops. All right, tell me. So 6 first, then math, then 5.
What? It's not. I swear you misremembered.
I believe you. 15, 6, 25. Oh, there we go. So it does. All right, so we got it. So you hit the 6 root first. So you do it in order. You hit the 6 first, then hit math, it'll give you that root. Then you put the number in, hit enter, and it'll give you 5. There you go. If you're using a graphing calculator. But I hardly ever use the graphing calculator. That's why I don't know it, because... Yeah. Okay, enough of that. I'm wasting time, because that's not even going to be on the... It wasn't? Okay. So let's see. Do I want to do that? Yeah, I can do this. So what if I had the cube root of negative 125? That really doesn't, that looks like 3 times. I should make that a little smaller. There we go. What about this? Well, it looks like we can't have a square root inside of a, or we can't have a negative, inside of a square root. But guess what? This is not a what? It's not a square root. So can we have a negative inside a cube root? Absolutely, because you can have a negative times a negative times a negative equals a negative. All right, so you can. You can't have it inside of a even root. You can't have a negative inside of an even root. Does that make sense? Because a negative, if you go even number of times, that's always going to be a positive answer, so it can't be negative. To get a real number answer, you know it's going to be imaginary, right? We've talked about that. So what is this? 125. It's 5, isn't it? And it's not just 5, but it's negative 5. Why? Because negative 5 cubed is negative 125. Make sense? Okay. What if I had this? We just talked about it. What if I had the 4th root of negative 16? We talked earlier what the 4th root of 16 was, but what's the 4th root of negative 16? That's right. You cannot take an even root of a negative number. All right? So there's no solution for this. All right? I'll just do that. Make sense? What if you had, they do this a little different, but what if you had the cubed root of this? Because I looked at this for a while. I mean, there's an easy way to do it, but they did it. I'll just do it the way I do it. If I was to do this problem right here, what does this mean? This means the cube root of 27, oops, not 7, 27 over, what do you think? Cube root of 8, good. What's the cube root of 27? It's just 3. What's the cube root of 8? It's 2, okay? But they really haven't taught you this rule just yet. They're going to teach you a version of it in about 2 seconds now, okay? Everybody with me on that? All right, so that's kind of that. They give you a couple other examples. You can look at those yourself, but I need to move on. So this next thing, I've referred to this in my geometry classes before. I never could remember what the name of it is, but it's called the product property. It's easy enough. Product meaning what? Multiplication, right? Of radicals. Okay? And here's basically what it says. We've done this before. We actually did one at the very, very beginning when I rationalized the denominator. We actually used this property. All right? So it's one that you can probably do. And I'll show you a quick little example. Then we'll do some examples that are maybe a little bit tougher. All right? So if you had this, this is an n whatever root it is, okay? Square root, cube root, fourth root, whatever, okay? So this works for any types of roots. And if these two numbers are being multiplied in the middle, guess what we can do? We can break this up into the nth root of x, what do you think? Times the nth root of y, all right? So we could do something like that. So for instance, if I had, I don't know, I'm just making something up, okay? 8, all right? I think I've taught you how to simplify this. Like what times what is 8? 4 and 2, right? Now, here's where we use this property right here. What does it say? If I got two things multiplied together inside of a root, I can put them, this is how I say it, put them into their own individual roots, okay? This is square root, so I'm going to put square root of 4 times what? Square root of 2, all right? That works, doesn't it? That to this property. And now you can just simplify it if it can simplify. Sometimes it doesn't simplify, but you could. So the square root of 4 is 2. You can't simplify that, and so that's 2 square root of 2. All right, we use that a lot. If you're going to multiply two things together, could be more than two things, but what if I wanted to multiply those two things together? All right, how could I simplify that? Well, I could put it under one big square root, couldn't I? So this time I'm going from this direction to this direction, right? These are individual square roots. I can put them both underneath. So it'd be 3 times 2. And what is that? It's the square root of 6. Make sense? All right, pretty easy. So let's do some examples. This is example 2. And there's an A, B, and C part to it. So this time we're going to do the cube root of 8x cubed y to the 12th. All right, what does that theorem tell us? Or that property, I should say. It's not a theorem. We could take the cube root of this by itself, and this by itself, couldn't we? Let's do it. After a while, you get used to this. You probably won't have to write out this step. All right, but right now, let's do it. So it's the same thing as the cube root of 8. This is the same thing as the cube root of what? X cubed. And this is the same thing as the cube root of y to the 12th. All right, we already talked about this. What's the cube root of 8? It's just a 2, right? 2 times 2 times 2, right? Or you could write it like this. Watch. You could have written 8 as 2 cubed and kept it under a cube root and then simplified it. Because that'll help us look at these the same way. So what really happens? That cube root and that cube, what do they do to each other? Just cancel each other out. I'm left with a 2. It's kind of a long way around to get to that, right? But that's basically what's going on. What about here? I got a cubed root and I got something's being cubed right here. What happens there? They cancel out. So what am I left with? Just an x. You with me? Let's do that intermediate step right here. Could I write y to the 12th so it's something cubed? What cubed is equal to y to the 12th? X to the, or y to the 4th, right? Everybody see that? Remember the rule for exponents? If I have an exponent taken to another power, I multiply the exponents together, all right? So check it out. What do I have? What happens to that cube root and that cubed? They cancel each other out. What am I left with? Y to the 4th, and there you go. That's how we simplify that. So we're just basically just practicing our rules. That's all we're doing. I mean, is this like some kind of engineering, scientific, physics kind of a thing? No. But there are times where you do have to simplify radicals, and that's what we're just trying to do right now. Okay, so that was part A. Let's do another one. Let's do a 4th root this time. 4th root. And this is 81, a to the 16th, and then b to the 8th. They made this kind of easy. Let's go back up to this for a second, all right? Do you see how we were left with a y to the 4th? Take a look at this 12 and take a look at that 3. What do we basically end up just doing? Just dividing, right? 12 divided by 3 is 4. 3 divided by 3 is 1. Everybody see that? Okay, same thing here. When you got to this part, 3 divided by 3 is 1. So it's 2 to the first. Yeah? Let's do the same thing here. What's the fourth root of 81? I'm going to kind of skip some of these intermediate steps. Yeah, 3 times 3 is 9, and another 3 times 3, that's 4 of them altogether, right? That's 81. Would you agree? So the fourth root of 81 is just the number 3. What about this? You could sit there and write this as something to the fourth power, couldn't you? But what's an easier way to do it? 16 divided by 4 is 4, so this is going to be what? A to the fourth. Do you agree? All right. And what about the b? B to the second, that's right. If they divide evenly, they're not always going to divide evenly, and we're going to have some examples here in a second that are not going to divide evenly. We've got to think about it a little bit. But if you really wanted to do that intermediate step thing, what do you got? This is 81 is 3 to the fourth, but you're taking the what? Fourth root of it, right? A to the 16th is a to the fourth to the fourth. Yes? Everybody see that? That's a to the 16th. Because, again, what do you do with the exponents? You multiply them together. 4 times 4 is 16. And then what do you do here? This is the fourth root of what? Is something being taken to the fourth power here? Yeah. B to the second is being taken to the fourth power. Would you agree? Yes? Anybody still here? So the fourth root and the fourth power cancel each other out. So what happens here? That cancels, you're left with a 3. That cancels, you're left with a to the fourth. The fourth root and the fourth power cancel, I'm left with a b squared. That's kind of like your intermediate step. But after you get used to these, you should just be able to go from right here to right here and not have to write all that stuff out. Make sense? But this is the y. All right? Let's do another one. What if I had this? Oops. This time, it's just a square root. So if you don't see a number out in that little spot right here, it's just a square root. And I bet you, as soon as you see this, you can tell me what's going to happen. What's this? This is a square root this time. Talk to me. Yeah, there's no solution to this because I'm taking the square root of what? Of a negative. There's no real solution. There is a solution, all right, but it's going to be an imaginary solution, all right? There's no real solution to this, all right? So you could just say no real roots. I think that's what the book says. No real roots. Or you could just say no solution. It's fine. If you wanted to do that, that means the empty set. Okay, the empty set means there's no solution. You could write that. I'll know what you're talking about. Just say no solution if you wanted to. Make sense? All right, let's keep going. This next part is a little bit weird, but let's do it. What do I got? 10 minutes? Okay. All right. This next little part, you guys asked about it earlier. I said I'd get to it in a few minutes. This is where it is. Okay, so you need to be careful when you have stuff like this. Watch. When x equals negative 3, let's find out what the square root of x squared is going to be. All right? Oh, wow. How'd you know that? Did you look? That's good. Well, you were correct. So what are we going to do? Put in a negative 3 in for the x, correct? And then what does it say to do? You square it. It's under a square root. So what is... Now, this is where you got to be careful. Okay? It looks like, oh, that square root and that square cancel each other out. My answer is negative 3. But you don't want to do that. You want to do the math inside of there first. What's negative 3 squared? It's a positive 9, isn't it? Everybody see that? Okay, and what is square root of 9? It's 3, right? So when you have something like this, your answer is not just x, it's the positive version of x. Okay?
So when x is negative 3, x is 3. I don't understand like the.
No, x isn't equal to 3. This is equal to 3.
Okay.
Okay? Not x is equal to 3. So the square root of x squared is equal to 3. Because it looks like you could just cancel out the square root and the squared and get a negative 3. But you can't. You got to do the math inside of there, right? And then you get a 9, and you just use the positive version of it. Now, I know that I've said this before. A lot of times I would have said this, that the square root of 9 is equal to positive and negative 3, right? We've done that before, haven't we? If I said x squared is equal to 9, right, what did we do? We took the square root of this side, square root of this side, but I put the plus or minus in front of it. This is very nuanced, and I don't know if I can really explain the nuance of this, but when you're actually solving for x in this situation and you're square rooting, you can say that x could be plus or negative 3. All right? When you're doing a solution, when you're trying to find what x is equal to, all right? You can get this. But if I just said, what is the square root of 9? It's equal to the absolute value, okay, of whatever the square root is. All right, so if I just said, what's the square root of 16? Don't tell me it's plus or minus 4. Just tell me it's just 4. It's the absolute value of 4, which is just 4. So you could just say just 4, okay? Again, I don't know if I 100% understand that, but this is what I've been told, is that when you're solving for x and you're taking the square root of both sides, yes, you can put the plus or minus there. And we've done that, haven't we? We've done that quite a bit, actually, this year. But if it just says, what's the square root of 25, then you would say what? It would just be 5. Okay? Because if you put that into a calculator, it's not going to give you a plus or minus. All right? Okay, enough of that. So let's do an example like that. Thought I'd get through this today. I don't think I will. So what if we have 25 x to the 14th? Okay. So let's just do them individually. Oh, forgot this. Let's write this down first before I do this. I should have put it in a box and I didn't. It's almost was hidden. All right, it says the nth root of x to the n, or it's not or, basically I'm just rewriting what that says right there. What is that? The nth root of x to the n, right? I just wrote down in symbols what that thing means right there, is equal to, now watch, it's equal to x, the absolute value of x, if the root, right, that nth root, the n, is even. I shouldn't put equals, I should put is, even. And it's just equal to x, it's just equal to x if n is odd. So let me do a super easy example. So what if I said the cube root of negative 8? Let's not do it like this. Not put the 8 there. Let's make it 2 cubed. 2 cubed. Everybody see that? So if you had something like this, this is an odd root, or an odd, yeah. The n is odd, correct? So in this situation, I'm not going to put the absolute value because it wouldn't be true, would it? All right, because this is negative 8. The cube root of negative 8 is negative 2. So this would just be equal to x. So what is my x? That's my x right there. So what's that equal to? That's a negative 2. But if I had the fourth root of negative 16, what's negative 16? That's negative 2 to the 4th, correct? Okay, so what if I had this? So this is even, isn't it? All right, so I can't just say it's negative 2. All right, that's incorrect. It's the absolute value of negative 2, which is just a 2. And we would get that if we would multiply that out, right? Because negative 2 to the fourth would be positive 16. The fourth root of 16 would be positive 2. All right, so that's what that thing right there is telling you. So let's go back to this. So I have the square root of 25, which is just a 5. What about this? The square root of x to the, remember this is a square root, so what can I do with those exponents here? This would be x to the what? 7th. But this is a what? An even root, so what do I need to do to that even thing right there? It's the absolute value, okay? So whatever the answer is, it's the absolute value. Because remember, this was what? X to the 7th squared. Would you agree? So whatever this is has to be in the absolute value. If this is even, all right, if it's even. If it's odd, we didn't need the absolute value. Let's do another one. B. What if we put a negative out in front, then we put 49, and we go y squared and z to the 12th. Let me take a quick peek real quick at something. I think that's right. I just want to make sure. Oh, okay. I got it now. Okay, so the negative really doesn't have anything to do with anything. Okay, I'm just going to keep the negative out there. It's not under the square root, so it doesn't bother me too much. What's the square root of 49? 7. Now, let's watch very carefully. Okay, this is the square root of y squared. What's the square root of y squared? It's the absolute value of y, isn't it? Everybody see that? All right, so right, that squared right there and that square right there is the absolute value of y. What's this going to be? This is going to be z to the what? Like what? Z to the what squared? Z to the 6 squared. Agreed? Now, you would think you would put that in absolute value too, don't you? But we're actually not going to do that. Why not? Why don't I put that in the absolute value? Because when I take something to the 6th power, even if it was a negative, what's it always going to be? It's always going to be positive anyway. So is there any use, any reason to put that inside the absolute value? No, because it's always going to be positive anyways, because any number to an even exponent is always going to be positive. Does that make sense? Like right here, why did we have to put it in here? Because x to the 7th could be a negative answer, couldn't it? Right? If x was negative. And this means I have to take the positive version of it. But right here, I don't need it in absolute value, because if I'm going to take it to the 6th power, that already is going to make it positive, so I don't even have to worry about it. But the y, that's to the 1st power, isn't it? All right, so y could be a negative. Would you agree? And then according to this, I have to make it, I got to force it to be positive. So that's how you would write your answer, right there. Isn't that crazy? Yes. All right, well, there was 2 or 3 examples I didn't quite get to, but they're kind of like what we just finished doing. Okay, very similar to it. So I'm still going to assign you the homework. I think you can. You can give it a good shot. So 1 to 41 odds. Okay, so it's 7-1. So it's section 7-1. You're doing, what did I say? 1 to 41 odds. You're just doing the odds. That's only like 20-some problems. Only. Some of these are super easy, though. All right, so there it is. Why does that look like a 2? It should be an S. All right, enough of that.